We'll conclude Module 1 with a discussion of higher order systems. That is, systems of equations that have more than two we have to deal with. Typically, you might see three. In general, there's mathematical theories that deal with systems of linear equations of arbitrary order. This is linear algebra. We will only focus on how to do a 3x3 system, so 3 variables and 3 equations. That looks something like this. Here, I have 3 variables, x, y, and z, and I have 3 equations. There are general approaches for solving this that are beyond the scope of this course. What I'll show you is an example of how, with a few clever algebraic manipulations, we can proceed largely as before. The basic idea is to use what's called Gaussian elimination, or row reductions. But all this kind of fancy talk just means that we're going to take the equations and add and subtract them in order to simplify things. So the idea is just to do algebraic manipulations to isolate pairs of variables and to use that to solve the equations. Keep in mind that for CLEP questions, if you're given a system of equations, it might be more rapid to, instead of solving it directly, to check each of the 5 answers and see which one satisfies it. Just something to keep in mind. So let's look at this equation, or this system of equations. I have x plus z equals 1. Also, I need 2x plus y to be equal to 1, and also 3y minus z to be 2. So how are we going to do this? Well, I'm going to call these equations 1, 2, and 3. So I'll start by adding 1 and 2. So I'll get x plus z equals 1 plus 3y minus z equals 2. So I get x plus 3y, the z's cancel, equals 3. So now I have a relationship between x and y. But I also have a relationship between x and y from, well, I'm sorry, that's equation 3 here. It looks like I've written 2. But I also have an equation on x and y from 2. So I'll say equation 2 is 2x plus 2y equals 1. So I know 2x plus 2y is 1, and x plus 3y is 3. So those two together are a pair of lines, and I'm looking for their intersection. So I can solve it by saying, well, I know that x equals 3 minus 3y from adding equations 1 and 2. And I also know that, looking at this, if I subtract 2y and divide by 2, I get x equals 1/2 minus y. Let's just check this. Yes. And then I can equalize those. So I know that, 3 minus 3y is equal to 1/2 minus y. So that tells me that 5/2 is equal to 5/2 y. So I know that y is equal to 1. And then I can go back and solve for the rest of them. Oops, made a mistake somewhere. Ah, that's the mistake. This is 2, not 3/2. And then here I get 5/2. Right, so then I have y is equal to 5/4. Sorry about that. And then I know that x is equal to 1/2 minus y, so 1/2 minus 5/4. So that's negative 3/4. And then to get z, I'll say plug into equation 1. So I know that negative 3/4 plus z equals 1. So that z is equal to 7/4. Okay, so I can check this, x plus z. So x is 3/4, z is 7/4, that's 1. 2x is negative 3/2 plus 2y. It's 5/2, so 1, if I add those together. And then 3y is 15/4 minus z, which is 7/4, so 8/4, which is 2. So all I did there is go back and just plug all of these things in and check that all three equations are satisfied. So that's sort of the general procedure for this type of problem. I try and do some algebraic manipulations in order to isolate pairs of variables. So I isolated x and y in two different ways. One was from equation 2, and another was from adding equations 2 and 3. So that gave me two relationships between x and y. So that was the same as solving a system of x and y alone. I solved for x and y, and then I went back and solved for z. So believe it or not, this is about as simple as these equations get. There could have been more complicated aspects to this, but I think this is about the most that you should expect to see on the CLEP exam.